Alright, this is our last video on sound, and we are going to talk about the Doppler effect and sound intensity. Alright, the Doppler effect first is an apparent difference in frequency based upon the speed of the waves. So what's happening for the Doppler effect is there's a police car, let's say. He's driving along, and, well, if he was stationary and he put out a frequency, it would reach you like this. But now, let's say he starts coming to you for a totally unrelated reason. Now, what's happening is he has a forward velocity as a policeman. So what happens is he is closing the gap between each of these different sound waves in terms of the frequency. So every time his siren makes a sound, now what's happening is he's going a little bit faster. So this distance here, x, between each sound wave, we'll call this x prime, is now being shortened. So what's happening is as he's going towards you, the frequency you hear is going to be going up. If he's moving away from you, the opposite would happen. There's now a bigger space between these two consecutive frequency pulses, and here the frequency would actually go down. What happens to the speed of the wave during all this? It stays the same. All right, so that's a general idea of a Doppler effect. We're going to solve a problem with it later. But first we're going to talk a little bit about sound intensity. All right, so loudness and frequency are two different things. Sound intensity was invented by Alexander Graham Bell because he invented the telephone and he needed a way to manage in terms of how loud you were yelling into the microphone and what somebody could hear on the other side. So sound is a log base 10 system of intensity. Don't worry, we're not doing any log base 10 math computations. We just have to know how much louder the sound is. For every 10 decibels that sound is increased, it's being heard 10 times louder. What does that mean? That means if you turn up the radio from 30 decibels to 50 decibels, you are listening to music that is now 100 times louder. So to go from 30 to 40 to 50, every time you move up 10 decibels, it's 10 times louder. So 10 times 10 is 100 times louder. What if you went from 40 to 70? So 40, 50, 60, 70, 10 times 10 times 10. That would be 1,000 times louder. Okay? All right, now back to Doppler. Doppler effect. Here is your equation. So this little f prime over here, that's the frequency that we are going to be looking in order to solve. This v is the speed of sound of the wave. For us, it's typically going to be about 340. The velocity of the observer is you. You are the observer. Velocity of the source is the police car, fire engine, train, whistle, whichever. Now, over here, they give you plus or minus. It's actually, each of them is minus or plus. So it depends on if you're going towards it or moving away from it. How does that work? Well, you can think about it individually. If that is coming towards you, the frequency would have to be higher, right? So you would want your numerator to be greater than the denominator. So the velocity of the source would have to be subtracted. So every time it comes towards you, you subtract it. Every time it's going away from you, you would add it. Likewise, if you were going towards it, you would also want the numerator to be higher, so you would add when you're going towards it, and when you're running away from it, you would subtract. All right, so what does that look like in terms of solving a problem? Let's say a police car is chasing you for an unknown reason with a siren at 600 hertz. He's traveling at 40 meters per second, and you are only going 30. So here is our policeman in his nice police car. Here are you driving your mom's minivan. Don't stand a chance. 30 meters per second, and he's going at 40 meters per second. And he has 600 hertz of frequency telling you to pull over. All right, so we're going to set up our equation. So you put 600 out front. That is the frequency of the source. Velocity of the wave. Velocity of the observer. Velocity of the source. All right, so we don't know if it's plus minus yet. Since he is moving to the right, you can compartmentalize it and say he is going to catch up to me. So if I were just standing still and he were moving towards me, the frequency would be higher. So because that, I want my numerator to be greater than the denominator, so I would subtract. Now if you just look at you as the observer, say I am moving away from him as fast as I can. So because I'm moving away, the frequency should be lower. So the numerator should be less than the denominator, so I should also subtract. So when I do my subtraction in the top, I get 310 divided by 300 times 600. That means that the frequency that I hear in my car is 620 hertz. Since he has an overall greater speed than me, that means that the overall difference in our velocities means he's getting closer. So it should be higher, so everything checks out. So that's it for sound.